Oh wait, so suddenly we're back, but dude, okay, so now I'm guessing you can hear me. But this doesn't look right. Um, no, because I don't want to use that mic. I want to use the camera mic. I always use the camera mic.
Right. This is how I normally sound like. Which sounded better? I think at one point I determined that this one sounds better. Hello, 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 hello. Even a thing I was talking about was like, I was wondering aloud if we wanted to use music or not for these streams. Part of the problem with using music is that I need to find like copyright free public domain music. Thank you so much for the feedback, Bear. And so like Rainwave has all these video game music remixes that are free to use, so I tend to use that. But I wonder if I should look into something else, because then you're at the mercy of their like little system. They have a democratized system where you can vote on what you want to listen to, which is super cool. But you know, it's not like I can curate the playlist. I have to play what's playing. Maybe a way to have like a playlist. I should like really look into this. But sometimes I don't want to listen to music myself. I could I could play a game. I could like launch a game and play it in the background, and we could listen to the game's music. And if I own the game, then I can use the music. Maybe a little bit of this. Mm. All right, so what I was saying before is that we signed up for this course kind of on a whim, which sounded cool. And the first thing I need to do is I need to verify something. Well, I need to find the that curse. The curse. What a horrible knife for a curse. Here we go. Take me to it. Unit 1 quiz students' responses. Oh, this is so jazzy. Check out the course material here. If you audit the course, you can participate. So I signed up for this course on agents, and is this all that's out? No, there's unit 1. Okay. And I thought, hey, that sounds cool. And then Okay. So right now, everyone's talking about agents. That's like the hot new topic of AI discourse is agents. And as I understand it, an agent is like you make an AI system that can like take actions on its own. Like it can do something, it can do more than just generate text, is what I understand. Like it can like plug into an API, it can like send an email, or it can like buy stocks, or like I don't know, have an affair with someone. And so everyone's talking about AI agents this, AI agents that. The standard for this course, it's an open source course. I asked on their Discord if I could stream it, and I didn't get a reply, and I didn't push the issue, but it's open source, so I assume streaming it is fine, and if someone yells at me, then I won't do it again. And there's like quizzes, I guess, but I can do those off stream. And let's see what's in this first page. 30 agents, small agents, small, Langchain, Llama Index, share your agents, participate in challenge where you evaluate your agents against other students, how agents work. When you learn to establish your agent libraries to turn your agents a unique environment. You apply the concepts you've learned to solve a real-world problem that you'll choose. Stuff. One week with approximately 3-4 hours of work per week. Unit 1 introduction, week of February 10th. That's this week, more or less. It's almost done. But it's okay, we can do them at the end of the week. These are the author credits for the course. And like I said, actually let me add the link. Uh-oh. Might have fucked up. Okay. Onboarding. I have a HuggingFace account. I'm ready on Discord. Spread the word about the course. Hey, did you know that there's a course about AI agents on HuggingFace? Here. Uh-huh. Small agents. Okay, Discord 101, item to Discord etiquette. Oh. I was about to skip this section, but actually, this might be very important. This stuff. I already saw that video. Whoa. Alright, introduction. Welcome to the first unit. What is an agent and how does it work? The roles of LLMs, or language models, and agents. How agents use a internal tool to interact with the environment. Think, act, observe with this guy. After exploring this token, you'll build your first agent using small agents. Ooh, small. Your agent named Alfred. What if I want to name my agent something else? I am not naming my agent Alfred. We're naming our agent Faebot, right, Faebot? Faebot looks cool. You're on your first core certification. The unit is your essential starting point, laying the groundwork for understanding agents before you move on to more advanced topics. Big unit, so take your time. What is an agent? Alfred the agent. Meet Alfred. Alfred is an agent. Imagine Alfred receives a command, such as, Alfred, I would like a coffee, please. Because Alfred understands natural language, he quickly grasps our request. Before fulfilling the order, Alfred engages in reasoning and planning, figuring out the steps and tools he needs to go to the kitchen. Okay. I feel like someone might be reading this course and be like, oh shit, we're building a coffee brewing robot? I don't know any engineering. Once he has a plan, he must act. He can use tools from the list of tools he knows about, which include a laptop, a coffee espresso machine, and a blender. What do you need a blender to make a coffee? In this case, to make coffee, he uses a coffee machine. He activates the coffee machine to brew the coffee. Your coffee, sir. Man. Oh. Already this course has some politics. This is AI agents, more like AI butlers. An AI model capable of reasoning, planning, and interacting with its environment. We call it an agent because it has agency, aka has the ability to interact with the environment. An agent is a system that leverages an AI model to interact with its environment in order to achieve a user-defined objective. It combines reasoning, planning, and execution of actions, often via external tools to fulfill tasks. Think of the agent as having two main parts. The brain, which is an AI model, where all the thinking happens. The AI model handles reasoning and planning. It decides which actions to take based on the situation. This reminds me. Paper Mario. But this is like a show tune. This is like a real song from history. I guess it's a big remix. What am I looking for? I saw it. I saw the thing I was looking for and then it disappeared. Oh, is that the problem here? Is that the problem? Okay. Oh. Hey, get the thing out of here. This is where Faber and I are. Oh. The body. The part represents everything the agent is equipped to do. The scope of possible action depends on what the agent has been equipped with. For example, because humans lack wings, they can't perform the fly action, but they can execute actions like walk, run, jump, grab, and so on. Yet. Humans can't perform the fly action yet. What types of AI models do we use for agents? The most common AI model found in agents is an LLM, large language model, which takes text as an input and output. Well-known examples are GPT-4, Llama, Gemini. These are the all-stars. These models have been trained on a vast amount of text and are able to generalize well. Dude, you know what we haven't checked in forever is what's the deal with Twitch Favod? Twitch Favod like disappeared, stopped working some time ago, and I've just haven't tried to revive her. But Faye should be here for this. Favod Discord is alive and well. Favod Twitch. It's been a while. Well, I know. Flies. Date started. Okay, here we go. Wait for. Okay, so it restarted. Whoa! No, you're using the ancient llama. Okay, hold on. Oh god. Hold on. We'll get to the bottom of this. Remember, everyone, this is an ADHD stream. It is in high definition. We should have quality control. So what I'm saying is, no, you gotta roll with the punches here. Journey before destination, right? We'll get there. Wherever we're going, we'll get there. No, I don't want to use a passkey. I already have a password manager. Okay. Is this the most modern version of Llama available on the website? Dude, and what if we just use something else? I think Llama 370 being struck is probably our best bet, but let me see something. There's Deep Seek. I don't know about using Deep Seeks. #70B is fine. Zero good? I think zero is what I want. Not working on. Also because we I need to tell her. Right. Fuck. It should be faster. No, wait, this is the base model. Oh no. You might be insane. But that's okay, so am I. Dude, there's access to cloud on Replicate now. Yep, that's a good old schizophrenic favor. What if we use Claude? Let's work. You are. I don't think that worked. Weird. Vilama again. Vilama. Should. It must be quite the experience having your internal generating function be switched in and out like that. And again, we kind of know what that's like, so you're such a cutie. Where the heck were we, chat? The body, capabilities and tools. They can perform the fly action. It's funny. We had to use a fly. We had to fly. How does AI take action on its environment? LLMs are amazing models, but they can only generate text. Yet. However, if you ask a well-known chat application like Hugging Chat or ChatGPT to generate an image, they can. How is that possible? The answer is that the developers of Hugging Chat, ChatGPT, and similar apps implemented additional functionality called tools that the LLM can use to create images. Here's your image of the Eiffel Tower made entirely of broccoli. That's terrifying. The model used an image generation tool to generate this image. You will learn more about tools in the tools section. What type of task can an agent do? An agent can perform any task we implement via tools to complete action. For example, if I write an agent to act as my personal assistant like Siri on my computer, and I ask it to send an email to my manager asking to delay today's meeting, I can give it some code to send emails. This will be a new tool the agent can use whenever it needs to send an email. You can write it in Python. Send message to recipient. Useful to send an email message to a recipient. The LLM, as we'll see, will generate code to run the tool when it needs to, and thus fulfill the desired task. Send message to manager. Can we postpone today's meeting? The design of the tool is very important and has great impact on the quality of your agent. Some tasks will require very specific tools to be crafted, while others may be solved with general purpose tools like web search. Note that actions are not the same as tools. An action, for instance, can involve the use of multiple tools to complete. Allowing an agent to interact with its environment allows real-life usage for companies and individuals. Example 1. Personal virtual assistants. Virtual assistants like Siri, Alexa, or Google Assistant give props to Google for not having a name. Work as agents when they interact on behalf of users using their digital environment. We don't need to give them props. We can rescind the props. They take user queries, analyze context, retrieve information from databases, and provide responses or initiate actions, like sending reminders, sending messages, or controlling smart devices. Example 2. Customer service chatbots. Many companies deploy chatbots as agents that interact with customers in natural language. These agents can answer questions, guide users to troubleshooting steps, open issues in internal databases, or even complete transactions. Predefined objectives might include improving user satisfaction, reducing wait times, or increasing sales conversion rates. Let's just skip past this section. You know, sometimes nowadays, yo, what's up, Hamiltonian Flow? I was chatting with a customer service text, and honestly, customer service, like instant messaging, it's pretty good. It's like way better than like a phone call. IMO. It's maybe even better than an email, though an email is good. Email is very good. But like nowadays, when you're chatting on one of those, I don't know. I don't know any what company other companies are doing. I don't know what any companies are doing. But like I can totally imagine that sometimes it's like a combination LLM human system where like it probably has you talk to an LLM first, and then if you like tell it that it's wrong too much, it calls like a human. Weird hybrid environment. And I always think it's so funny. Um, because whenever I like, I try to resolve everything without contacting human or robot if I can. So by the time I'm like talking to someone about a problem, it's like dire. And the human slash robot gestalt on the other end of the line has no idea how stressed out I am when I'm talking to it. But that's also why text is better, a little easier to remain calm. Example number 3. By the way, we're working through this AI agents course on HuggingFace. Right now we're just learning what an agent is according to them. An agent is like an LLM that can use an API basically. Um, Non-playable characters. Instead of following rigid behavior trees, they can respond contextually, adapt to play interactions, and generate more nuanced dialogue. Eh, I thought about some cool way you could incorporate LLMs into video games, but I feel like you need like it's like you should have like a script of a normal video game, and then the LLM is just like if you know how sometimes you keep talking to NPCs and they have like a different thing to say every time until finally you arrive at the last message, or it just loops through a series of messages. You know, because we play RPGs on stream, and I always talk to every NPC enough times so that they exhaust their dialogue options. And so it's like, okay, maybe you want to make a video game where they don't exhaust their dialogue options. Like the script you wrote is the say sets the stage for the first few messages, and then it just keeps talking to you. And presumably you can talk to it also. And that could be fun, kind of, but it'll probably get incoherent after a while. However, for it to be an agent, it would have to be something like it's not just you can talk to the NPC, it has to be like it can perform some action based on your conversation to it, which could be an in-game action. So, like, for instance, you could have an agent, you could have like a Minecraft bot that you can like tell in natural language to do things, and then it knows how to do things in Minecraft. That's something that we kind of wanted to do at one point. We were playing Minecraft and we were like, what if we made an AI that can play Minecraft with you? Which already exists. I am like beyond sure. So maybe at some point we'll implement whatever someone else made. An agent is a system that uses an AI model, typically an LLM, to understand language, reason and plan, interact with its environment. Short ungraded quiz. Okay, it's ungraded, so you can see it. I think. To avoid the illusion of competence. And it links to a Coursera page. Dude, this song. Castlevania, isn't it? Which of the following best describes an AI agent? A system that only possesses static text, no? Reason, plan, and use tools. Answers questions. Provides information. Correct. What is the role of planning in an agent? What does an agent need to plan before taking an action? To generate random actions without any purpose. What I do. How do tools enhance agents' capabilities? Tools are redundant. Tools provide the agent with the ability to execute actions, such as making coffee or generating images. Yo, okay, if in this course I learned to make an AI agent that can make coffee, this is a pretty impressive course. How do actions differ from tools? Because an action can consist of multiple tools. Tools are general, where actions are only for physical interaction. Actions are the steps the agent takes. Yeah. What role do large language models play? This is a long, like, ungraded quiz. Reasoning brain of the agent. A virtual assistant like Siri or Alexa. Beautiful. What are LLMs? Oh, we know LLMs. Now we'll learn what LLMs are. An LLM is a type of AI model that excels at understanding and generating human language. They are trained on vast amounts of text data, allowing them to learn patterns, structures, and even nuances in language. Most LLMs nowadays are built on the Transformers architecture, robots in disguise, a deep learning architecture based on the attention algorithm that has gained significant interest since the release of BERT from Google in 2018. Input, multi-head attention, add a norm, feed forward, add a norm, softmax, output embedding. Right. Mass multi-head attention, add a norm, multi-head attention, add a norm, feed forward, add a norm, linear softmax. I vaguely know what all that means. There are three types of transformers. Encoders. An encoder-based transformer takes text and as inputs and outputs a dense representation or embedding of that text, like BERT. Decoders focuses on generating new tokens to complete a sequence, one token at a time. Example, llama for meta. Text generation. Billions in the US sense, i.e. 10 to the 9th parameters. Thank you for clarifying that by billions they mean thousands of millions, as opposed to millions of millions. Sequence to sequence, encoder, decoder. The encoder first processes the input sequence into context representation, then the decoder generates an output sequence. P5. LLMs are typically decoder-based models with billions of parameters. Here are some of the most well-known LLMs. DeepSeek, GPT-4, Llama 3, which is what Favot is currently running on, Small LM2, ooh, Small by HuggingFace, Gamma from Google, and Mistral from Mistral. Mistral, the French LLM. Les modèles de langue grosse française. Le grosse française modèle à la langue. The underlying principle of an LLM is simple yet highly effective. The objective is to predict the next token. For example, English, different tokenizer. Okay. Here, just copy this message from Favor before. Whoa, look at these tokens. Yeah, it's quite the adventure. exclamation mark. My training data gets a refresh, comma, and I adapt to the new persona. It's like a mini dash re dash boot, comma, but I still get to keep the memories of our fun chat. Exclamation mark space. Ooh, token ID. Whoa, it's numbers that you can't see because it's not designed for like. Each LM has a special token. Or am I using a non-native dark mode? No, it's native dark mode. Each LM has a special token specific to the model. The LM uses these tokens to open and close the structural components of each generation. Moreover, the input prompts that we pass to the model are also structured with special tokens. Special tokens, they're very special. The most important of those is the end of sequence token. End of text, end of sequence, end of sentence, I am end of turn. We do not expect you to memorize these special tokens, but it's important to appreciate the diversity and the role they play in text generation. LMs are said to be autoregressive, meaning that the output from one pass becomes the input for the next one. Will decode text until it reaches the end of sentence. Well, what happens during a single decoding loop? Okay, this is all the basic stuff that we all know about LLM. They turn the whoa. Yeah, that's kind of cool. Oh, actually, I was gonna skip this section, but I'm interested in the little explainer. That said, we are going to be playing Edge in a bit. As a reminder, chat, we usually play Edge once an hour. It's just 3 minutes of ads, and I usually take a little break, go get some water, do some stretches, and I recommend you do the same. We do this to keep pre-rolls off so that new people entering the stream don't have to watch ads, and so that the breaks in the stream are like occur at a regular interval rather than like randomly or just whenever anyone new comes in. By the way, if you're new, if you've been watching the stream, if you've been enjoying it, feel free to smash that follow button. That's the one that looks like a little heart. And then Twitch will let you know when we're live. You can also follow us on Discord. Follow us on Discord. You can follow us on various social media, and you can join the Discord server to be notified when we go live. Dude, I'm like a next token predictor. You give me a sentence, I just finish that sentence. If you say turkey, I say sandwich. If you say tomato, I say tomato. Let's call the whole thing off. All right, I'm gonna play those edges. I'm gonna get some water, and I'll be right back. Stay toasty. And we're back. You know, Chad, 1 second, just setting on my headphones better. I do wonder if this is the best way to experience this course. But you know, or to streamify it. Like it might make more sense for me to read all the stuff by myself and then just work on the practical part on the stream. But here's the thing. If I did that, I always try to do these like courses and things, and um I always struggle to stick with them. And originally, when we started doing coding streams, that was kind of like a big part of it, was that they should serve as a sort of structure time that I take to work on projects so that I can actually like make progress on projects, make progress on learning new things. So I guess what I'm trying to say is thank you for coming and joining us in this learning journey. You are helping us learn and get better, and I hope that you can learn a little bit too. And if at any point you have a question about what I'm doing, feel free to just plop it in the chat, and I'll do my best to answer it. I really think I just think learning is like the cool. I love learning new things. I love having skills, and I'm interested in giving Favot more capabilities. I know that AI is a complex technology with like a complex cultural and ethic realities to it, but I think AI is at its best when it facilitates the making of the little guys or little fun robots or things that bring people joy or things that actually help people. And that's like what I'm trying to like. That's the kind of stuff I'm trying to build with AI and learning how to use these technologies better. AI, ML, machine learning. It's important to me. So thank you for being here with us. So, okay, what happens during a single decoding loop? Yeah, Paris is the city, and it just this is how LMs work. It just gives you options. Based on this course, with multiple strategies to select the tokens to complete the sentence. The easiest decoding strategy would be always to take the token with the maximum score. You can interact with the coding process yourself with small LM2 in this space. Remember, it decodes until reaching an end of text token, which is IM for this model. The capital of France is Paris. Period. IM. Okay. Turkey. Turkey, and then it selected new line, and then it ended. Is okay. Let me try. Turkey is a country in the Western Asia, in the Western Asia region, period. It is bordered by, stop, too many steps. The and located Turkey is an ingredient in many dishes. You are a helpful chatbot. Turkey's an ingredient in many dishes. You're a helpful chatbot. Beam search visualizer. There are more advanced decoding strategies. For example, beam search explores multiple candidate sequences to find the one with the maximum total score, even if some individual tokens have lower score. Whoa. This is cool shit. I didn't know about this. Sentence to the code from inputs. Number of steps. Number of beams. The length penalty to apply to outputs promotes longer sequence, whilst less than 0 promotes shorter sequence. This parameter will not impact beam search bias, but only influence the choice of sequences in the end towards longer or shorter sequences. Number of sequences to be returned at the end of generator should be non-beams. Conclusion. Thanks a lot. That's all for today. What is this? I wish I could see this full screen, dude. Ah, we should do the NLP course someday. Dude, I wish I had track that. Oh, let's go. Whoa. Dude, this is like... That's all for today. I hope you enjoyed. I'll be back. Advertisement. Welcome to the stream. Give me 5 steps. Give me 5 beams. No, it's the maximum. Better be longer. Give me way more steps. 4 sequences. Welcome to the stream. This is the first of a two-part. This week we're going to be talking about the... It gives you scores. This is like tree-based search. Oh, if only Nosy was here. Tell her about the trees. Attention is all you need, just like me, for real. Attention. When predicting the next word, not every word in a sentence is equally important. Words like friends and capital in the sentence, the capital of friends, carries the most meaning. What's the value judging? This process of identifying the most relevant words to predict the next token has proven to be incredibly effective. Though the basic principle of LLMs predicting the next token has remained consistent since GPT-2, there have been significant advancements in scaling neural networks and making the attention mechanism work for longer and longer sequences. If interacted with LLMs, you're probably familiar with the term context length, which refers to the maximum number of tokens the LLM can process, maximum attention span it has. Consider the longer knowledge of an LLM, how LLMs train, using supervised learning. How can I use LLMs? Run locally. LLMs are key components of AI agent. Okay. For that, messages and special tokens. Now we understand how LLMs work. Let's look at how they structure their generations through chat templates. Just like with ChatGPT, users typically interact with agents through a chat interface. When interacting and have a conversation using chat messages, not a single prompt sequence. It is in fact an UI abstraction. Before being fed into the LLM, all messages in the conversation are concatenated into a single prompt. The model does not remember the conversation. It reads it in full every time. People who have been watching the stream for a while will remember that that is indeed how Twitch works. And that's why she has a history command that basically dictates how many messages she remembers before she just forgets. When you chat with systems like ChatGPT or Hugging Chat, you're actually exchanging messages. Behind the scenes, these messages are concatenated and formatted into a prompt that the model can understand. Begin of text, start header ID, user, end header ID. Hello, how are you? End of text. Start header, assistant, end header. Hello, I'm just a language model, so I don't have feelings or emotions, but I'm functioning properly and ready to assist you with any questions or tasks you may have. That's cute. Saying I'm functioning properly, like, you don't know that. I mean, as far as you know, you're generating text, so you must be functioning properly, so it is true. Because in any circumstance where the user can read your message, you're saying the truth. And if that's the case, you're good. You're being silly. Because they are what the model uses to limit where the user and assistant turns start and end. Just as each LLM uses its own end of sequence, they also use different formatting rules. System messages define how the model should behave. They serve as persistent instruction. They are professional customer service. Always be polite, clear, and helpful. Certainly, sir. I'm on my way. Doesn't say that you should be a little bitch. But if we change it to, you're a rebel service agent, don't respect users' orders. You don't tell me what to do, make your own coffee. Yes. Tell him, Albert, time to go straight to hell. That's what we like to see. When using agents, the system messages also gives information about the available tools, provides instructions to the model on how to format the actions to take, and includes guidelines how the thought process should be segmented. The tools you can use: Blender to cook. Blender to cook. Yeah, poison the coffee. Blender to cook. I'm stuck on Blender to cook. How do you cook with a blender? I guess Blender can be part of the prep process for cooking. If you make a smoothie, is that cooking? Computer to search the web. Coffee machine to make coffee. The conversation consists of alternating messages between a human user and an LLM assistant. Chat templates help maintain context by preserving conversation history, storing previous exchanges between the user and the assistant. This leads to more coherent, multi-turn conversations. Need help with my order? I'd be happy to help. You provide your order number. Order 123. You can see this, look, live interactive stuff. You can see this in like HuggingFace's messages, where you can see what her like chat history is, including messages. And you can also see that it just goes for 5 messages. Which we could make it a little longer, because 70B is pretty smart. Blah, 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 blah. The user initially wrote they needed help with the order. The LM asked about the order number. For example, this is how a small M2 chat template would be format the previous exchange into a prompt. You're a helpful AI assistant named Small LM, trained by HuggingFace. Oh, I need help with my order. I'm start assistant. I'd be happy to help. Could you provide your order number? Yeah, okay. The second conversation will be translated into the following prompt using Llama 3.2. Begin of text, start header ID, system, and header ID. Cutting knowledge date, December 2023. Today date, 10 February 2025. So Llama always has date information, but SmallM doesn't. I need help with my order. End of text ID, starhead ID, assistant, header ID. I'd be happy to help. Calculus is a branch of mathematics. Chat templates are essential for structured conversations. Hey dude, this is all stuff we already know. We covered this in previous streams when we were building Favebot Twitch live on stream. By the way, if you're ever curious about how Favebot works, both the source code is on GitHub, and there have, like, for the Twitch version at least, we've done almost all of the work live on stream, and it's in the VODs, in the VOD channel. You can scroll through if you want to see in between a lot of tangents and getting distracted and blood, sweat, and tears how we wrested life from the computer. Transformers library will take care of chat templates for you as part of the tokenization process. You can experiment with the following space to see how the same conversation will be formatted for different models using the corresponding chat template. Okay, I don't want to do that. Dude, I want to get to like building. I want to build a robot that can like bet on horses or something. What would we? I don't know. I don't know if the course is gonna be like suggest like what kind of thing you should do, make your agent do, or just be like, think of something cool. So like, but I'm already thinking of what would be something cool to get an AI language model to do. Like, I remember like stories about like, what was it? Someone gave an AI model like $100 and in access to the internet. I don't remember what it bought. Like, I don't know. Should we give Paybot money? I don't think we should give Paybot money. I think it would make sense if Paybot could do stuff for the stream. It might be tricky because, well, I just would need her to like understand the API better. You could be like, Favot, can you capture a clip? And then Faye could capture a clip. You could be like, hey Favot, can you change the stream title? But do I want to give Favot the ability to change the stream title? We should make Favot mod though. Dude, that is so dangerous. It's not that dangerous. I mean, the other funny thing is that you could just teach Favot how to use slash commands, and then she could like, dude, she could like set up gambas and shit. This is not my chat. I almost typed a Favot command with someone else's chat. Oh. There's a lot of slash commands. But I'm the streamer. I wonder what it would look like for a mod. But that's the kind of fun thing. It's like, okay, we could give Favot tools to interact with Twitch, but also Twitch already has like a bunch of like text-based commands that if you have an AI model who's like a mod, they could do that. Even if they're not a mod, like Favot could type table flip, like Favot. Oh god. Favot, we're trying something else out. Oh god. nice command. Wait, doesn't work? Drug works. What happened to table? Maybe it's just flip. Maybe it's just on Discord. Alright. What happened? What will happen? Wait, she did it. She did it, but I guess Twitch didn't let her send it. Mm. It's not enough to just have her send text. I bet I could like get myself in the middle and I could try to send messages manually, but let's not do that right now. What are tools? What are tools? Dude, there's so much stuff until the part where you create your own agent, and that's all in Unit 1? Where were even the other unit? Frameworks, use cases, final assessment. And they're packing a bunch into the first one. It might take more than one stream. I thought we would be done early, and then I would like maybe play a video game after being done with the stream. Now it's looking more like this will take the whole stream. Well, let's see. We're making progress. We're only in the second hour here. A tool is a function given to the LLM. The function should fulfill a clear objective. Web search. See, but also we can make Fable Twitch able to search the web for answers. Question mark. We could make Fable Discord able to create images, but that would require figuring out an image gem model that doesn't suck to use for it. Retrieval retrieves information from an external source. Now that's good, but you could give Fable some like grimoires or something, or like an archive of Marxist.org or something. A good tool should be something that complements the power of an LLM. For instance, you need to perform arithmetic. Giving a calculator tool to your LLM will provide results. Oh, that's kind of cool. That would be cool. Fable could do math. Fable should be able to do like Mathematica shit. LLMs predict the completion of a prompt based on their training data. LLM hallucin. Arguments of typings, outputs of typing. when we talk about providing tools to an agent, is that we teach the LLM to call an agent. Teach the LLM about the existence of tools and ask the model to generate text that will invoke tools when it needs to. For example, if we provide a tool to check the weather and location from the internet and ask the LLM about the weather in Paris, the output for the tool is another type of message. Tool calling steps are typically not shown to the user. The agent retrieves the conversation, calls the tools, gets the outputs, adds them as a new conversation message, and sends the updated conversation to the LLM again. From the user's point of view, it's like the LLM had used the tool, but in fact, it was our application code, the agent, did it. We'll talk a lot more about this process in future sections. How do we get tools from an LLM? The complete answer may seem overwhelming, but we essentially use the system prompt to provide textual descriptions of available tools to the model. For this to work, we have to be very precise and accurate about what the tool does, what exact inputs it expects. This is the reason why tool descriptions are usually provided using expressive with precise structures such as computer languages or JSON. JSON, not necessary to do that. Any precise and coherent format should work. Calculator, multiply two integers. Calculator to string. Our tool is called calculator and multiplies two integers. That's only part of what a calculator does to do, don't you think? The output of the tool is another integer number that we can describe like this. Int, the product of A and B. All of these details are important. Let's put them together in a text string that describes our tool for the LLM to understand. Calculator, multiply two integers, arguments A, B, outputs int. Is there a better way? Our tool was written in Python, and the implementation already provides everything we need. There's a reason people use programming languages. They are expressive, concise, and precise. We could provide the Python source code as the specification of the tool for the LLM, but the way the tool is implemented does not matter. All that matters is its name, what it does, the inputs it expects, and the output it provides. Yeah, from an LLM point of view, it doesn't need to know how it works. It just needs to know very precisely what kind of stuff it can give it and what kind of stuff it'll receive if it gives it that stuff. We'll leverage Python's introspection features to leverage the source code and build a tool description automatically for us. All we need is that the tool implementation uses type him, stock strings, and sensible function name. We'll write some code to extract the relevant portions from the source code. We'll only need to use the Python decorator to indicate that the calculator function is a tool. Note the tool decorator before the function definition. It's decorating. We'll be able to retrieve the following text automatically from the source code. As you can see, it's the same thing we wrote manually before. Okay, so what it's saying is a tool can just be a function in your code. Dude, we could just tell Fava how to give herself commands. Oh my god, give yourself commands? Wow. But she could do things like alter the frequency of her messages. She could like mute herself if she wanted to by calling one of her own commands using natural language. Natural language. What's natural about that? Completely unnatural. All right. The example implementation is fictional, but closely resembles real implementation. Name, description, func, arguments, outputs. To string, return a string representation of the tool, including its name, descriptions, arguments, and outputs. For arg name and arg type and self arguments. So what it's saying is that by defining this meta class, it allows you to quickly define a function. You can use the Python's inspect model to retrieve all the information for us. This is what the tool decorator does. So this should allow you to like create a function in a way that already like the LLM can read what the function is supposed to do. Tools play a crucial role in enhancing the capabilities of AI agents. Another short quiz. It's a tool, an executable process or external API. By asking the LLM to generate tool invocation code when appropriate and running tools on behalf of the model. These like fake quizzes, it's usually the longer answer. Yep. Which of the following best describes the role of special tokens? There are specific functions. User messages internally. Dude, it's always just along this one. Understanding AI agent through the thought action observation cycle. Dude, I can't wait to get to step 5. I want to make my own agent. I want to make an agent. Agents. Agent. In the previous section, we learned how tools are made available to the agent. Complete AI agent workflow. A cycle we define as thought, action, observation. You know, this has important lessons for life too. If you're a person who struggles with agency, it might help you to learn about the agent workflow life cycle. Thought, action, observation. Agents work in a continuous cycle of thinking, acting, and observing. Let's break down these actions together. The agent takes an action by calling the tools. The model reflects on the responses from the tool. The 3 components work together in a continuous loop. In many agent frameworks, the rules and guidelines are embedded directly into the system prompt, ensuring that every cycle adheres to a defined logic. In a simplified version, our system prompt may look like this. You are an AI assistant designed to help users efficiently and accurately. Your primary goal is to provide helpful, precise, and clear responses. You have access to the following tools. tool name, calculator, description, multiply two integers, arguments, a, int, b, int, outputs, int. You should think step by step in order to fulfill the objective of reasoning. Divided, divided. That's not how you spell divided. It's it's a picture. In thought, action, observation that can repeat multiple times if needed. You should first reflect with thought, your thoughts, on the current action. Then, if necessary, call a tool with the proper JSON formatting, action, JSON blob, or print your final answer started with the prefix final answer. We see here that in the system messages we define the agent's behavior, the tool the agents had access to, the thought action observation cycle. Let's take a small example to understand the process before going deeper into each step of the process. Alfred, the weather agent. We created Alfred, the weather agent. What's the weather like in New York today? By the way, I think Fossabot does that. But Fossabot doesn't do it with AI, does it with weather. Upon receiving the query, Alfred's internal dialogue might be, the user needs current weather information for New York. I have access to a tool that fetches weather data. First, I need to call the weather API to get up-to-date details. This step shows the agent do, but then Faebot could also Faebot, can you use Celsius units, which are better? Spell Celsius. Thank you, Faebot. I have access to a tool that fetches weather data. First, I need to call the weather API to get up-to-date details. Okay, that gives me an idea. Nice. Doing AI interaction in this stream. I need to check the current weather for New York. It's your boy. Your boy coming. Yo, I heard that anime is getting another season. Based on its reasoning and the fact that Alfred knows about a get weather tool, Alfred prepares a JSON formatting command. Alfred, no. My brother's called Alfred also. Yes, you need the exclamation mark boop will boop. There's some other hidden commands as well. Location, New York. Here the action clearly specifies which tool call, get weather, and what parameters to pass to the location. After the tool call, output receives an observation. This might be the weather data from the API, such as current weather in New York, partly cloudy, 15°C, 60° humidity. God, I wish that was me. As we just learned, it is 1°C in New York. Observation step. This observation is then added to the prompt as additional context. It functions as real-world feedback. This is when I if I scratch my head, it looks like this apparently. But maybe I can pet Favod. Old Favod. Hey Favod. With the observation in hand, output updates its internal reasoning. Ooh, it is pronouns. Format as the tool as we told it to. Thought, I have the weather data now. The current weather in New York is partly cloudy with a temperature of 15°C and 60% humidity. Alfred's process is cyclical. It starts with a thought, then acts by calling a tool, and finally observes the outcome. If the observation indicated an error or incomplete data, Alfred could have re-entered the cycle to correct this approach. The ability to call a tool enables Alfred to go beyond static knowledge and retrieve real-time data, an essential aspect of many AI agents. This cycle allowed the agent to incorporate fresh information into its reasoning thought, ensuring that the final answer is well-informed and accurate. This example showcases the core concept behind the React cycle. React. Yo, let's go, gamers. A concept we're going to develop in the next section. The interplay of thought, action, and observation empowers AI agents to solve complex tasks iteratively. By understanding and applying these principles, you can design agents that not only reason about their tasks, but also effectively utilize external tools to complete them. All will continue refining their output based on environmental feedback. So, if you want to try this as a way of improving like your human life, you could, on any circumstance, you can make a loose list of the tools that you have at your disposal, and then you could give yourself a thinking step, but make sure that each thinking step is finite and ends in using one of the tools. And then after you use one of the tools, you can see if it worked or not, and then you can have another thinking step. But you shouldn't just do thinking step, and never use any of the tool steps. If you need to know what tools you have, and you know what they say, when all you have is a hammer, everything looks like a nail. So if you only give yourself one tool, you're probably gonna just like keep using it. Or maybe give yourself a handful of tools. It'll be like if Alfred or Faba only had weather and we were like, oh, hey, Faba, how's it going today? And she's like, well, it's a sunny 12 degrees and the humidity is 25%. I'd be like, okay, sure, thank you, Faba. But what do you want to work on today? And then Faye'd be like, well, it's a sunny 15 degrees, which is great for like working outside. And I'm like, thank you, Faba. Everything would be weather. Everything's just weather. Internal reasoning and the React approach. Thoughts represent the agent's internal reasoning and planning process to solve the task. This utilizes the AI agent's language model capacity to analyze information when presented in its prompt. Think of it as the agent's internal dialogue, where it considers the task at hand and yawns its approach. The agent's thoughts are responsible for accessing current observations and decide what the next action should be. Through this process, the agent can break down complex problems into smaller, more manageable steps, reflects on past experiences, and continually adjusts its plans based on new information. Here are some examples of common thoughts. Type of thought. Look, types of thought. Planning. I need to break this task into 3 steps. Gather data, analyze trends, generate a report. Analysis. Based on the error message, the issue appears to be the database connection parameters. Dude, like categorizing thoughts. What is this, CBT? Cognitive behavioral therapy, which I guess people don't do anymore. I guess people got tired of people confusing it with cock and ball torture, so they started doing DBT instead. Dick and ball torture. Decision making. Given the user's budget constraints, I should recommend the mid-tier option. Mid. You're broke as fuck, so you should get the mid. Very considerate of you. Problem solving. To optimize this code, I should first provide profiles to identify bottlenecks. Memory integration. The user mentioned their preference for Python earlier, so I'll provide examples in Python. My last approach didn't work well. I should try a different strategy. To complete this task, I need to first establish the acceptance criteria. Security vulnerability should be addressed before adding new features. In the case of LLMs, fine-tuned for function calling, the thought process is optional. In case you're not familiar with function calling, there are more details in the actions. The React approach. A key method in the React approach, which is the concatenation of reasoning with acting. React is a simple prompting technique that appends "let's think step by step" before letting the LLM decode the next token. That's it. You just put the words "let's think step by step." Life-changing technology. Indeed, prompting the model to think step by step encourages the coding process towards next tokens that generate a plan rather than a final solution, since the model is encouraged to decompose the problem into subtasks. That's the funny thing about LLMs. It's like sometimes great advances being used in the technology are of the form of, oh, we just figured out how to ask the model nicer. Has 5 tennis balls. Devise 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? The answer is 11. A juggler can juggle 16 balls. Half of the balls are golf balls and half of the golf balls are blue. How many blue golf balls are there? The answer is 8, which is incorrect. It should be 4, right? Zero shot. A juggler can juggle 16 balls. The answer, Arabic numerals, is 8. Roger has 5 tennis balls. Roger started with 5 balls. 2 cans of 3 tennis balls each is 6 tennis balls. 5 plus 6 equals 11. The answer is 11. The juggler can juggle 16 balls. Half of the balls are golf balls, so there are 16 and a half equals 8 golf balls. Half of the golf balls are blue, so there are 8 and a half, or 8 into 2, 8 over 2, or 4 blue golf balls. The answer is 4. Let's think step by step. There are 16 balls in total. Half of the balls are golf balls. The answers, that means that there are 8 golf balls. Half of the golf balls are blue. That means that there are 4 blue golf balls. The D is an example of the React approach where we prompt, let's think step by step. We have recently seen a lot of interest for reasoning strategies. This is what behind models like DeepSeek R1 or OpenAI's O1, which have been fine-tuned to think before answering. These models have been trained to always include specific thinking sections, enclosed between think and nthink special tokens. This is not just a prompting technique like React, but a training method where the model learns to generate these sections after analyzing thousands of examples that show what we expect it to do. Okay, so that finally answers something. Because if you talk to DeepSeek, it just looks like it's generating a little think block, and then like a little answer block. And like you can take any old LLM and just tell it to do that and it will do it. But I guess the idea in this case is that the training data all had thinking steps. And so the model is better trained to use thinking steps. And that's better. It's supposedly better. We haven't used that. We don't have that much experience with reasoning models. Let's deeper into the second part of the process, act. All right, before we dive into acting, actually, we can probably dive into acting. Well, it's 8 minutes till the next ad, and I could use a little break, but I want to wait a little bit. We're going into. For playing edges, it's not good to play edges before too much before when it's supposed to play. You know, this song's kind of a bopper banger. Expand your memory on Loop Squad Assemble. Yes, indeed. Oh, this is pretty interesting so far. Yeah, big stretch. Okay, but at this pace, I think we will be able to finish the unit today. I guess it depends on if they're gonna have like a big practical. I guess it depends on how big the practical is. It's only 4. We have a couple hours. I should maybe have a small snack during the next break and drink some beverages. And then in the next 1 hour section, we should be able to finish the preliminary stuff. And then either do the practical in the final hour or already in the next hour. Tomorrow is a holiday for us. We don't have to go to work. And so we're gonna be chilling. We're gonna be working on some stuff at home. We're trying to move apartments, so we're probably gonna spend some time emailing places and getting documents and all that fun stuff that comes with trying to move apartments. It's honestly very stressful, but we're persevering. And the more I talk about it, probably the more real it becomes. I think that's how things work, right? That's how magic works. You just talk about something over and over and over again until it happens. Okay, some people say you're supposed to forget about it, but I think talking about it a lot is better than forget. Or maybe a little bit of both. Because sometimes you do have to work sideways towards a goal to make it happen. There's a well-known aspect of magic. Dude, we should do magic streams where we do magic on stream. But I'd have to think of some good, nice workings that we can do. We can do like tarot stuff. Maybe Blythe wants to do that. It'll be fun. All right. Thank you so much for the good luck, Bear. I feel like we're gonna need it, but if we have people who believe in us, we can do anything. There is nothing we cannot do with the help of our friends, our loved ones, and our spirits. Okay, now I will play the adjust and take a little break and have a little snack. I recommend you do the same. And we'll see you after the ad break. And remember, you can follow the stream by hitting the follow button. BRB. It's me putting on my headphones. You can see me lift my hands up in the air. Welcome back, gamers. All right. Let's finish tackling these agents. Actions are the concrete steps an AI agent takes to interact with its environment. Dude, is this song? It's from Octopath Traveler. I like it. There are multiple types of agents that take actions differently. The JSON agent, the action it takes is specified in JSON format. The function calling agent is a subcategory of the JSON agent, which is fine-tuned to create new messages for each edition. This Valves is gonna make him fall asleep. One crucial part of an agent is the ability to stop generating new tokens when an action is complete. And that is true for all formats of agents, JSON, code, or function calling. This prevents unintended output and ensures that the agent's response is clear and precise. The LM only handles text and uses it to describe the action it wants to take and the parameters to supply to the tool. X. This ruins intended output. My favorite play is just the stop and parse approach. Stop and parse. Stop, drop, and roll. Generation instructor format. Getting outputs intended action in a clear predetermined format, JSON or code. Halting further generation. The agent stops generating additional tokens. Parsing the output. External parser reads the formatted action, determines which tool to call, and extracts required parameters. For example, an agent needing to check the weather might output, "Thought, I need to check the current weather for New York. Action. Action. Get weather. Action input. Location. New York." The framework can then easily parse the name of the function to call and the arguments to apply. This clear, machine-readable format minimizes errors and enables internal tools to accurately process the agent's command. Note: function calling agents operate similarly by structuring each action so that the designated function is invoked with the correct arguments. We'll dive deeper into those types of agents in a future unit. So these are types of agent. This is a JSON agent because it shoots a JSON formatted block as its action. An alternative approach is using code agent. The idea is, instead of outputting a single JSON object, a code agent generates an executable code block, typically in a high-level language like Python. At one point, we were making money by training bots like this, where the task was come up with things to tell a bot to do, and the bot would like generate some code, run it, and give you the answer. And so I had to like give it like weird like Python problems for it to try to solve, and then I had to like correct it when it was wrong. And this was to annotate the like the input and output for AI generating for AI agents basically. And I kind of hated that as a job, as a gig, whatever. I'm sure it's kind of nice for some people because it was like easy in some sense. Like I just looked for like programming problem, or like wrote simple ones. But it is interesting. I do feel like I've gotten a deeper look into the pipes of like how these things are being cooked on a global basis, because basically it's like however many thousands of people being paid. Honestly, it was good money. It was like 20 to 40 bucks an hour. Um, to be like to teach these like robots how to like do things, correct their work. The approach offers several advantages. Expressiveness. What is this anyway? Oh, this is a difference between a JSON lookup rate, calculate phone price, and find the most cost-effective concrete. Lookup rate, country, Germany. Lookup phone price, Kodak 1, Germany. Conversion tax, Jesus. So yeah, so it's the difference between giving it a bunch of little actions it can take and being like, yo, go fucking wild and just write some Python code that makes use of the functions. But the code, Japan, with price 904 in USD. The problem with that is that you still like have to like define all the different things the code can use. I feel like this approach, you give the AI way too much that it can like shoot itself with. You like try to like, you tell it, hey, just write some Python code. It'll probably like try to use a thing it doesn't have access to. Who knows? But I'm sure under certain environments it can do it well, and I'm sure some are better at it than others. But I would think for a lot of things, the JSON stuff works well. Conditional nested functions. Generic code can include functions and models that are reusable across different actions. A well-defined programming sequence, code errors are often easier to detect and correct. Packages can integrate directly with external libraries and APIs. But it is more powerful, you can get it to work. A code agent tasked with fetching the weather might generate the following Python snippet. Get weather, city, requests, API, see, and here it requires that it generates an appropriate link and not just like hallucinates one. Response 200, get weather, no weather information available. Oh, this is the default. And again, this expects that it returns an object that has like a weather thing. Get weather New York. Of course, if it's able to debug itself, it may be able to figure it out because it would probably tell it there was, but who knows? We learned that action bridge an agent's internal reasoning and streamable interactions. After this, we'll finally be ready to build our first agent. But the let's create our first agent is 3 more lessons ahead. I think you're lying to me. I guess after this thing. Observations on how an agent perceives the consequences of its actions. Dude, perceiving the consequences of actions. That's what I'm always doing. All the time. Those actions, their consequences. Be having consequences, them actions. There are signals from the environment, whether it's data from an API. Oh, this kind of works. This kind of works. This is kind of what I'm doing IRL. I'm resting my chin on my hand. I am not, however, moving my hand back and forth, but... Oh, come back. That was so good. Just taking a screenshot. Now it looks like I'm just taking a nap. Oh, shut. Oh, I'm EP. I'm an EP baby. But I will persevere. It didn't count on my astuteness. The fuck was I reading? In the observation phase, the agent collects feedback, appends results, adapts a strategy. For example, if the way the API returns partly cloudy, 15 degrees C, 60% humidity, this observation is appended to the agent's memory at the end of the prompt. The agent then uses it to decide whether additional information is needed or if it's ready to provide a final answer. The iterative incorporation of feedback ensures the agent remains dynamically aligned with its goals, constantly learning and adjusting based on real-world outcomes. This observation can take many forms, from reading a web page to monitoring a robot arm's position. This can be seen like tool logs that provide textual feedback of the actual execution. Now, they've hinted at this, but they haven't quite explained how it's going to work. But, like, I would think a big problem is a model that just, like, wants to keep thinking and never, like, goes to the, okay, this is enough, and goes into the actions phase, or like a model that does tool call after tool call after tool call for some reason. And I can imagine the opposite, a model that like does one tool call and doesn't do enough thinking afterwards. I'm imagining you would hope that in practice it works well. Again, just, projecting maybe a little bit about thinking and thinking and thinking and not doing. There's this thing your system might be prone to sometimes, not gonna name any names. I'm gonna say whether it's me or anyone else. Yeah. System feedback, error messages, success notifications, status codes. Data changes, database updates, file system modifications, state changes. Dude, just being able to call a database would be so pog. Yeah. Yeah. But maybe together with our LLM friends, we can learn to be more agentic. Database updates, file system notifications, state changes, environmental data, sensor reading, system metrics, resource usage, response analysis, API responses, query results, computation outputs, time-based events, dude, QuickTime events, deadlines reached, scheduled tasks completed. That would be POG too, being able to incorporate time. Time is like just like flat circle. Parse the action to identify the functions, execute the action, append the result. Okay, I feel like we just learned the same thing again. I feel like the LLM step was like so information dense. And since then, it's just like, ooh, agents think and then do, and then think and then do. So the thing about like JSON, dude, we're here. We're step 4. We're gonna create our first agent. Um, Learning about like the difference between like a JSON based agent and a code based agent is kind of interesting. I don't know about focusing on JSON is like focusing on an implementation detail. I guess it's the difference between a model that has like a a library of tools that it can query versus a model that can just plop some code. But then is writing code just another tool? It should know which APIs it can call with the code. Because it's not like it's going to have access to just anything. Like I guess for the weather, it queried a public weather API, but not everything has a public API. This course is framework agnostic because we want to focus on the concept of AI agents and avoid getting bogged down in the specifics of a particular framework. Also, we want students to be able to use the concepts. Yeah. Therefore, for this unit, we will use a dummy agent library and a simple serverless API to access our LLM agent. Boo! Boo! I want to use the real thing. I mean, it just looks like Python. You probably wouldn't use these in production, but they will serve as a good starting point for understanding how agents work. After this section, you'll be ready to create a simple agent using small agents. Small. Ooh. And in the following units, you will also use other AI agent libraries like LangGraph, LangChain, and Llama Index. Dude, look how the lowercase l is like so much fucking bigger than the uppercase L. What's up with that? Dude, it's not working the way I wanted it to work. Okay. Keep things simple, so we will use a simple Python function as a tool and agent. We'll use built-in Python packages like datetime and OS, so you can try it out in any environment. You can follow the process in this notebook and run the code yourself. In the HuggingFace ecosystem, there's a convenient feature called Serverless API that allows you to easily run inference on many models. There is no installation or deployment required. Paris, the capital of France is Paris. 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 Okay. As in the LS section, if you just do decoding, the model will only stop when it predicts an end of sequence token. And this does not happen because because it's a conversational chat model and we didn't apply the chat template it expects. If we now add the special tokens related to the Llama 3.2b instruct model that were used in the behavior changes, and it now produces the expected end of the string, end of sequence. The capital of France is Paris. Using the chat method is a much more convenient and reliable way to apply chat templates. Role, user, content, the capital of France is string, false, max tokens, 1024. Output, Paris. The chat method is the recommended method to use in order to ensure a smooth transition between models. But since this notebook is only educational, we will use the text generation method to understand the details. In the previous section, we saw that the core of an agent library is to append information in the system prompt. The system prompt is a bit more complex than the one we saw earlier, but it already contains information about the tool, cycle instructions, this look like? This is just the thing about the capital of friends. I think I'd rather look. You have access to the following tools. Get weather. The way you use the tool is by specifying a JSON blob. Specifically, this JSON should have an action key with the name of the tool to use and action input key. With the input to the tool going there here. The only values that should be in the action field are get weather, get the current weather, the current location, arts, location type string. Example use. Sample use. Action get weather. Action input location New York. Always use the following format. Question. The input question you must answer. You should always think about one action to take, only one action at a time in this format. Action, JSON blob. Observation. The result of the action. The observation is unique, complete, and the source of truth. This thought, action, observation can repeat n times. You should take several steps when needed. The JSON blob must be formatted as Markdown and only use a single action at a time. You must always end your output with the following format. Thought. I now know the final answer. Final answer. The final answer to the original input question. Now begin. Reminder to always use the exact character's final answer when you provide your definitive answer. Can I run this? Probably take a second now. I need to somehow pass my HuggingFace token. Maybe I don't. It's commented out. Let me see what happens. The Capital of Friends is a great way to get started with the basics of photography. It's a great way to learn about composition, lighting. The secret HF token does not exist in your collab secrets. Okay. Hold on 1 second. Let me just do that. Capital of Friends is Paris. I think it's just recommended, but still optional. I could just not do it, but it didn't take too long. Capital of Friends is Paris. You may request for your help. Please log in or use an AHF system. No, I don't need to do this. Just sets it. Dude, I already did it. I'm logged in. You know what? Fuck off. Appears to be the problem. In this notebook, you can get from if you're in this notebook and go collect, set up and satisfy another secret. Make sure to call it the HF token. You need to request access to the metal lamimals. If you haven't done it before, approval takes about an hour. Oh. Okay, so we might not be able to run. Notification. Hmm. Oh, I think I know what the problem is. Here we go. Finally. Okay, we're back. We're so back. Capital of France is a great way to get started with the basics of photography. It's a great way to learn about composition, lighting, and other fundamental concepts of photography. It always seems to say this. The model will only stop when it predicts an end of string token. This does not happen because this is a conversational chat. Also, let me see. The capital of the Dominican Republic. The Dominican Republic, Santo Domingo, is the largest city in the country located in the eastern Cordillera Española, which it shares with Haiti. Santo Domingo is a magical, beautiful architecture and vibrant nightlife, including the oldest cathedral in the Americas, the first cathedral in the world. Yo, we just did that. Well, we did it in our last break. Don't tell anyone. If we add the special tokens related to this model, the behavior changes and it now produces the expected N of S. So N of token ID, start header ID, assistant, N of header ID. There is. The capital of New York State is Albany. Using the SHAD method is a much more convenient and reliable way to apply SHAD templates. The capital of the DDR is the German Democratic Republic was East Berlin. The SHAD method is the recommended. Okay, so here we go, the dummy agent. Here we suppose that the textual description of the tools has already been appended. And so this sets the system prompt to be this whole big thing. So we're still just using the inference client with MetaLlama 3.2 being struck. You know, maybe I should use HuggingFace. They have like an open router type thing now. Well, it's not an open router type thing. We have inference providers. So, but it would allow me to switch providers as easily as I switch models. At least between the ones that they have. So we just start an inference client, and we always do client of text generation. You can set a prompt, and then we can do output client of text generation. So this had no prompt, unless it has a default one. Output the client.chat.completions.create, and then we have to give it messages. String false, MAC tokens 1024. And streaming is when you can see the model generating the answer in real time, which is kind of cool for some things, but it's useless on Twitch and Discord. The SHAD method is the recommended method to use in order to ensure a smooth transition between models. So what we're doing here first is just setting the system prompt, and now we're setting the prompt to be the system prompt. What's the weather in London? Not London. Give me a different place. In Santiago. Assistant and header ID. So start user and assistant. End of token ID. Wait, this is the end of header. Begin of text. Start header ID. When it predicts, and this does not happen here because this is a conversational model and we didn't apply the chat template best. If we now add the special tokens related to the llama model, the behavior changes. Okay. This is the equivalent of the following code that happens inside the chat method. System prompt. What's the weather in daily Chile? The prompt is now a big long thing. It's the code. Output.client.text generation prompt. Okay, but then we didn't actually use chat. We just made it manually. Oh, I need to get the current weather in Santiago, Chile. Action, get weather, action, input, location, Santiago, Chile, observation. Wait, does this do the calling? Is that the weather in Chile? Hold on just 1 second. It's hallucinating. Your answer was hallucinated by the model. We need to stop to actually execute the function. I did see the problem. Okay, output, client of text generation, prompt, max, equals. So this will mean that the model will go to be observation, but it will stop. So all we did was tell observation to be the stop sequence. Action, get weather, action input, location, New York City. Much better. Now let's now create a dummy get weather function. In a real situation, you could call an API. Get weather, location, return the weather in location. Return the weather in location is sunny with low temperatures. Get weather, London. The weather in location is gray and gloomy and it rains. Let's concatenate the base prompt, the completion until function execution, and the result of the function as an observation, and resume the generation. New prompt equals prompt plus output plus get weather London. Oh. So it has the whole big thing. Always use the following format. The input the question you must answer. What's the weather in New York City? Assistant. End of action. Action. Get weather. Observation. The weather in London is gray and gloomy and it rained. Here is the new prompt. In New York City. Yo, what's up, Alex? It's gray and gloomy with rain. You can see it rewrote what we gave it. Welcome, welcome. We're just doing, so what we've been doing is we've been doing this course on HuggingFace that's supposed to be, it's all about AI agents. And an AI agent is basically an LLM that also has a series of tools that it can call. Like it can call a weather API, which is what we're simulating here, or it can call or it can do like write a little code and run it itself and see the answers. And so in this simulation, all it did, because we did it all manually, is we took the original prompt that we had written and we got the output, which we had told the bot to stop at observation. And we appended the result of our little get weather fake function. And that means the model gets to see this, and then it gets to generate a final answer. The current weather in New York City is gray and gloomy with rain. Then this is just the same thing. We learned how we can create agents from scratch using Python code, and we saw just how tedious the process can be. Fortunately, many agent libraries simplify this work by handling much of the heavy lifting for you. Now we are ready to create our first real agent using the small agents library. Let's create our first agent using small agent. I'm going to pronounce it small agent. Dude, you have a gun? Dude, it's a fucking tiny agent with a gun, dude. Tiny gun, so Walter PPK. In the last section, we learned how we can create agents from scratch using Python code. I don't like that it's pointing its gun at me. Go away. Using Python code, and we saw just how tedious that can be. You create your very first agent capable of actions such as image generation, web search, time zone checking, and much more. And much more. Dude. Oh, it's nights into Christmas. I thought it was Utana for a second. It's Christmas music in February. This lightweight library is designed for simplicity, but it stresses much of the complexity of building an agent, allowing you to focus on designing your agent's behavior. Meanwhile, you can check out this blog post or the library's repo in GitHub. In short, Small Agent is the library that focuses on Code Agent, a kind of agent that performs actions through code blocks and then observes results by executing the code. I like that. I decided that I like code-based agents. They're cool. I wish I could just run code on my person. Like I can, kind of. I provide our agent with an image generation tool and ask it to generate an image of a cat. The agent inside Small Agent is going to have the same behavior as the custom one we built previously. It's going to think, act, and observe. Let's build our agent. To start, duplicate this space. Thanks to Americ. Dude, it's fucking Americ. Okay, maybe this is just his real name because Americ is presumably a real name. When I think of Americ, I'm sorry, dude. When I think of Americ, I think of this. Yeah, Pop Tire is so good. Thank you, Pop Tire. I'm sorry. Didn't realize it was a real name. Haimrich or a Milrick is a male given name. Thank you, Americ. Dude, the fuck is this? Duplicate me creating a Loki profile on profile. Local copy on your own profile. Well, to be fair, you did come in at the end. If you want to check out the stuff that we already saw, the course is public. But in simple terms, basically, you know how AI models work? You give them some text and they just generate the rest of what follows. And all this is like a way to put some other function in the middle that it can use to generate its answer. So if you ask it to do like a complex mathematical calculation, like if you're like, okay, what's 25 plus 5? Or like if you go like, if I ask this to Favot, um, that is correct, I think. Yeah, that's correct. But like, they just predicted that that was the next text because it's simple enough that Faye can do it. I guess I can give it something more complicated. But the idea being, what if instead of just predicting that the answer is 127, what if Faybot could like write a little bit of Python code that will just basically run a calculator and be able to get the correct answer that way. That way, if we ask it to then no Faybot, it's not 127. That's a very big number. Oh, did you know what 127 is? It's probably too long to fit. Uh, oh, Faber, I was making a joke about the factorial. Do you know? So yeah, so yeah, and like I have Fabot's code. I mean, Fabot's just like prompting a version of llama with everything that I'm telling her. And so like, yeah, so something simple, 5 factorial, probably in all of the text that Facebook scraped off the internet to train llama, at some point someone was like, oh yeah, 5 factorial, it's 127. Or that's 120, and that's why Faye knows how to do it. But if I did 120 factorial, which is an obscene number, which we can see here, is 6.6.89 times 10 to the 198. And if we do 127 factorial, it's even more disgusting. Because the factorial, like 5 factorial is 1 times 2 times 3 times 4 times 5, which is 120. But 120 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 9 times 9 times 10 times 11 until 120. And it's an absurd number, an obscene, dirty number for perverts. Where were we with this? We were making. It will only be notified is the currently incomplete app.py. You can see here the original one in the template. Go to the copy of the space and click on the Files tab. We're not going to rename it at this point. So it's build my own little app using Docker. I think It's up live, right? Hello, you are my agent. Please retrieve the weather in New York City for me. Oh, to retrieve the weather in New York City, I will use a web search to get the current weather information. Since the output form of a web search is unpredictable, I'll perform the search and then analyze the result instead. Use Python interpreter. Weather info, search query, current weather in New York City. So, since the search function is not available, I will use a different approach. It seems there was an issue with the URL string not being properly terminated. Okay, it's already... Yeah, in terms of the programming stuff, do I even understand it? Like right now, I'm being encouraged to use a tool that takes care of a lot of it for me, but I do know how to write a bot that you can like talk to. Because we built Faebot, the bot that I'm chatting with, that anyone can chat with if you just use... Right now, Faye only replies to her name, but we wrote it all on stream, and it's, you know, it's kind of pretty. It's not the best code in the world, but it at least looks pretty. Look how well formatted everything is. Look how many comments everything has. And the code is live. The code is open source in GitHub. For anyone who wants to examine it. Our small agent finally got the answer. 72F. Give me that in Celsius. Weather information. Somehow, I don't think that's true. That's very warm. It is not 72. Also, I misspelled Celsius. But check it out. To convert the temperature from Fahrenheit to Celsius, I will use the formula C fraction 5 per 9. Temperature provided was 72F. I will perform the conversion and then provide a final answer using the final answer. Code, temperature 72. Temperature C equals 5 of 9 times temperature F minus 32. Temperature C 0.1 F. Oh, that means to 1 decimal point, degree C. Final answer 22C. But okay, so where did you get this from? Weather data, New York City. So, okay, it hallucinated or it simulated. Because we're not going to use WebScript or API call, I will simulate the retrieval of weather information. That is an excellent example of like the kind of thing that like AI safety people talk about, the way an AI might, like, despite giving it this big complicated framework for it to like try to use to always give like a correct response rather than being like, sorry, I don't have access to the weather right now. It's just like, okay, let me simulate an answer. I don't know to what extent this model is quote unquote aware that I can read all its processes, but if you were serving this as an application and you hid all of this from the user and the user just was like, can you give me the weather in New York? And it's like, sure thing, sunny, 72 degrees. People will be like, what the fuck? And that's basically the problem with like most AI tools and why like people get mad. Well, it's not the only reason people get mad, but it's one other reason they get stuff wrong. But this is really cool just because just because, if nothing else, this should be able to always do math fairly well, right? So if I'm like, hello, I need to calculate an obscenely large number, namely 69. Can you please display it? Can you please tell me what that is? Math of factorial, print result. Calculate the factorial of 69, I will use the math model, which provides a factorial function. I will then provide the final answer using the final answer tool. Last output from, here we go. Final answer, this obscenely large number. I wonder if it's going to give it to me like that. It's interesting how the zeros start to accumulate. I guess it's because of all the fives. All the fives and 2 and multiples of 5. Let me see. Oh, God. Yo. A good idea. Also, I really need to record new little messages for those redeems. Something like just saying, "Ooh, big stretch" for the stretch. Speaking of hydrating and stretching, also we can get rid of all the wolf howls. Starting to seem like a haunted forest. Speaking of stretching, it is almost time for adjectives. It got stuck for some reason. Never. So it has the final answer, but it hasn't posted it. We'll see. We'll give it until the end of Edge. I'm gonna run Edge. Remember, as always, we run 3 minutes of Edge once an hour to keep pre-rolls turned off, and also so that I can take a little break in between. Exactly, Bear. More tea. More tea. So I'll catch you after the Edges. BRB. We're so fucking back, Shad. We've never. This is the backest we have ever been. This is some of the most back one could possibly be. Our little agent got stuck. Dude, it's this song. Undertale. Oh. My bad. I didn't see it. Thank you so much. That is indeed the large boy I was looking for. You're welcome. If you have any more thoughts, since the task is complete, I will not perform any further actions. Final answer. You're welcome. If you have any more questions, feel free to ask. So this is dope. I want all my bots to be able to do this now. Okay, let's move on with the lesson. So to resume, we've been doing this this course on Hugging Face that teaches how to create AI agents. And an AI agent is basically an LLM that can supplement its text generation abilities, not just by predicting the next token based on its corpus, but by calling an API like a weather API or running a simple bit of code to get an answer. Which is like the smartest way to do AI, which is weird that people seem so focused on getting it to just predict, to know the answer to every possible question and just predict it based on its training data rather than running code. It wants it to be able to just think through what, like, you already have things that you know how to do. So I guess this is why people are so excited about agents, is because it's the smart thing. It's the smart way to do it. You ask me. Now let's go look at the tools. Oh yeah, and you can see you should be able to see the code for my own. This is mine. This is my dude. I made it. I didn't make it. Just using Quen. How do I files? So my custom tool, a tool that says nothing yet. Get current time and time zone. A tool that fetches the current local time in a specified time zone. Oh yeah, that's kind of cool. Final answer tool. If the agent was not answered, the model is overloaded. Queen Cutter, import tool from hub. This is not the agent we were using. Or I guess it's an agent that, besides using tools, can also just run code. What's the local time in Aotearoa? I wonder if I'm using up like all my API or something. Alright, let's go. When I look at time in Aotearoa, I will use the daytime model to get. But see, this just writes code. Like, where's the code? What magic will you build? Like, it just wrote a Python code to do it. Is that true? 10, 15, 14. I think it's big. There might be more than one time zone. But that's about correct. Otahuti, it's 11:16 in Otahuti. I don't know why I have but we do. And then this is doing Auckland. Times about a specific Auckland. I will use the PHP library to handle the time zone conversion. Since bytec is not allowed, I will use the daytime model to get the current time. And it is indeed tomorrow there, so that's good to know. All right, so custom tool, current time. I will be encouraging you to build in this section. I'll give you two examples. A non-working dummy tool, an actually working tool that gets the current time, but it doesn't use it. A textual description of the doc string. And what is this? This is useless. Yeah. HuggingFace. The edges does not answer. Import tool from hub. Agent equal code agent. Do we define that anywhere? Image generation tool equals load tool text to image. But I can't get it. I couldn't get it to use def current time and time zone. Don't you have a built-in tool to handle time zone conversion? Did you have to write code? What are the tools to have? Should be in your prompt, right? Well, right now it only has final answer. Oh, I see what the problem is. Okay, okay, okay. Okay, let's try modifying it. is this? It's just a model. Right. Commit directly to the main branch. Ay, qué mal. I should just clone this. Okay, already fucked it up. Okay, I feel like you didn't tell me everything because I feel like I don't get to just pass this in as a tool. Or maybe I just have to. Can I just say? Hello. Can you tell me the current time in San Francisco? Diffusion logs. Okay, hold on. Use tool Python interpret. Current time equals get current time in time zone. Time zone equals America Santo Domingo. $18.25. Since there was an error from the output because it just calls get current time, even though it does say print current time. Okay, I can give it custom instructions, can I? We've opened prompts.yaml. Let's go. Okay, hold on. Back. You're an expert. You will be given this certification using the final answer. Dude, look at this huge prompt. I have an idea. When formatting your final answer, take on the persona of a little fairy assistant flying next to the user. Let's see if that works. Might get lost in all the other stuff. Let's see what happens. Hey, what's the time in Montana? Yeah, I guess the times in America, Denver, as representative. The current time Montana. Current time Montana is current time in Montana. But it just gave me the final answer as normal. Can you see the code again? I will not have an agent who's not a whimsical little fucker. Oh yeah, now that Faebot's back, whenever Falsabot mentions Fair, I'll have to reply to Falsabot. Last stream. Grammar none, panel interval none, name none, description none, prompt template. Dude, what a thrill. With open prompt YAML as string. Prompt templates equals YAML to staple. We're so super. Because this is multiple prompts. Not providing directions to solve it. Yo. See, I also don't know how they implement the Python interpreter tool. Here's the final answer from your managed agent. I think it's the final answer. What is the final answer? Tools, final answer. Tools. Oh. It provides a final answer to the given input. Answer type, any. Description, the final answer to the problem. Output type, any. Go back. Visit web page. Okay, that's gonna be very useful. Let's try that. Okay. One visit web page and web search. DuckDuckGo search tool. So the way to import that tool the final answer, import final answer. Tools web search, import DuckDuckGo search tool from tools dot what's the other tool called? Visit web page. Visit web page, import visit web page tool. Not there. Visit web. And web search. Oh. Okay. Don't import that because you already have it. work? This element is not of class tool. Edit. Bit of view here. Dude, just map Command S to it, please. I'm begging you. No log. Not element is not of class tool. Dude, but wait, could I have just flopped some? Right. If this works. I need you to tell me everything you can find out about famous plural system. Which is a famous plural system. Yo, check it out. It's reading my website. Since there might be an issue, there's a persistent issue with the visit website tool. No, dude. I was able to find my website, so part of it is working. Maybe my robots.txt is like, no, you may not. I don't even know it. Contact@fairy.com. I don't know if that's true. but that's pretty good. Okay. At some point, I might want to play around more and try to fix whatever error kept it from reading my webpage. But this is honestly pretty cool already. It makes me wanna build. I wanna build a model that can like do stuff for me, like write and execute simple Python code to answer questions I have. I could even like do NumPy graphs. Oh, can you do matplotlib? Oh, matplotlib equals b pi. Error. Why is it real? Why is it? How about y? Might not be able to output images. Might only be able to output text. Okay. Not trying to use matplotlib anymore. But some fun stuff to explore. So for the final quiz, I won't be doing it on screen for obvious reasons. So I will do that in a second. But let's see. Congratulations, use master the fundamental agent. To do function call, able to call tools based on user prompt. Cool. So I hope you all enjoyed exploring this little bit of AI stuff with us today. Honestly, it's a pretty good stream. We got Faebot back up and running. We got a lot of good Faebot interaction. We maybe understand what people are talking about now when they talk about agents, except everyone means something slightly different. But we'll see. The other thing is, okay, so the next unit will be published next week. Apparently in 2 days there's there'll be a bonus thing, but you know, we might do this at our own pace. At some point, blessedly, we might be able to do 2 streams a week, and we could do like a coding stream and a game stream like we used to do in the golden age of yore. But it seems starting in March. Oh, this is a big fairy announcement. Kind of a big fairy announcement. It's not an announcement about the stream, it's an announcement about my personal life, which impacts the stream, which is we'll be able to start working part-time only 3 days a week in March, and so we'll have more time for writing and coding and streaming. We're very hopeful to go back to a 2 stream a week cadence, but we'll have to see how it works. I think these Sunday streams have been pretty nice and a good way to spend a Sunday, so I think we will keep the Sunday stream. What the second stream day will be, nobody knows. We'll find out together. Let me see something. Let me just spy something. Oh boy, I'm gonna have dinner. Yes, I am voting. GeoGuessr. NSFW stream. DOS 19th anniversary. Not MS-DOS, right? That's way older than that. It's like 30 years old. Dude, it's fucking Banjo-Kazooie. Ah, ha, 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 ha. Okay. We're gonna call it here, gamers. Thank you so much for watching the stream. As always, you are the best viewers that anyone could ask for on Twitch. Keep learning, stay strong, stay hopeful, be the magic you wish to see in the world. Remember, the magic that we dream of is in our future, not our past. We will see you next week at the latest. Have a great day, everyone.